Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos, Ukobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5 still on intermolecular forces. It says the table below shows the boiling points of ammonia and water respectively. Then we are given the table as we can see here, ammonia with a boiling point of negative 33 degrees and water with a boiling point of 100 degrees Celsius. 5.1 says define boiling point. So we say boiling point 5.1 is the temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. Right. So this is the definition for 2 marks. Is the temperature at which the vapor pressure of a substance equal the atmospheric pressure. Right. Then 5.2 says explain the difference in boiling points between ammonia and water. So we know that ammonia has the chemical formula NH3 and water has the chemical formula H2O. Now we've already stated that if a hydrogen is either bonded to an oxygen, a fluorine, or a nitrogen, then we say the type of intermolecular forces that exist there are the hydrogen bonds. Then looking at your ammonia and water, we can see that they both fit this criteria. Here we have the hydrogen bonded to a nitrogen, and then here hydrogen bonded to an oxygen. So the type of intermolecular forces in both the substances are the hydrogen bonds. But then now, what is contributing to this difference in the boiling point if we say they both have the same intermolecular forces? Can we say it is the molecular mass? Not exactly, because if we can look at the molar mass of NH3, if we calculate here, that's 14 plus 3, we're going to have 17 grams per mole. And then if we were to look for the molar mass of H2O, we would go, that's 2 plus 16, and then this will give us 18 grams per mole. Right. So we can see that there's not pretty much a big difference in the molecular mass. So they relatively have the same molecular mass. So the molecular mass cannot be the factor that is affecting the boiling point. Now you have to know that when it comes to the ammonia and water, there is a special factor that is affecting the physical properties. And that factor, we call it the site of hydrogen bonding. Right. So note this, in a case whereby they give you ammonia and water and they want you to explain the difference in the boiling points, just know that the factor affecting the boiling point will have to be the site of hydrogen bonding. And this is how you go about explaining that one. So you will tell them NH3, which is ammonia. NH3 has one site of hydrogen bonding. While H2O, water, has 2 sites of hydrogen bonding. Now, you will have to tell them the force of attraction between the molecules of water is stronger than in ammonia. Right. So because of those 2 sides of hydrogen bonding, that means the forces of attraction between the molecules of water are stronger than the forces of attraction in ammonia, right? So let's say the forces of attraction between the molecules of water are stronger. So let's edit here are. So the forces of attraction between the molecules of water are stronger than in ammonia, right? And then now that means more energy is needed to overcome the intermolecular forces. The intermolecular forces in water. Thus, it has a higher boiling point. Boiling point. So that's how you put it there. NH3 has one side of hydrogen bonding, while H2O has two sides of hydrogen bonding. The forces of attraction between the molecules of water are stronger than the forces of attraction in ammonia. More energy is needed to overcome the intermolecular forces in water. Thus, it has a higher boiling point. Right. So note that every time we are talking about the ammonia and water, they ask you to explain the difference in boiling point. It is not because of the intermolecular forces. It is not because of the molecular size, but it is because of the sites of hydrogen bonding, the number of sites of hydrogen bonding. So NH3 has only one side while water has two sides. So the one with two sides obviously will have stronger intermolecular forces and therefore a higher boiling point. Okay, now let's go to 5.3. It says, which substance will have a lower vapor pressure? Give a reason for the answer. Right, so lower vapor pressure. Obviously, this one, if we can check here, we do not see any vapor pressures. We are only given the boiling point. So in order to answer this one, we need to know the relationship between boiling point and vapor pressure. So boiling point is inversely proportional to vapor pressure. So that means the substance with the lower vapor pressure must have a higher boiling point. Now, looking at this, we can see that it is definitely water. So we're going to say water, and then to give a reason for our answer, we say it is the one with so we say it has, so we say it has the highest boiling point. It has the highest boiling point. So higher boiling point, lower vapor pressure. Right. So that's how you were supposed to go about answering this question here for a total of 8 marks. So please press the thumbs up button if you have enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, what are you waiting for? Please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.